Welcome to our masterclass on writing clean Python. Simply put, clean code is about prioritizing readability and long-term maintainability over clever shortcuts. By adhering to the PEP 8 style guide, you ensure your work is consistent and professional. Remember, code is read far more often than it is written, so always aim for clarity. Think of your source code as a technical document intended for other developers or your future self. Every line you write should reduce cognitive load, not increase it. Avoid clever one-liners that obscure intent. If you have to choose between a compact, complex line and two clear, descriptive lines, always choose clarity. Naming is one of the hardest things in programming. A function named D tells me nothing, but calculate_sales_tax clearly describes its purpose. Use descriptive, pronounceable names for functions and variables. By replacing vague identifiers with meaningful nouns and verbs, you eliminate the need for excessive comments because your code becomes self-documenting. Vertical whitespace is your best tool for creating visual rhythm. Just as a book uses paragraphs to group ideas, your code should use empty lines to separate logical blocks. Don't crowd your code. Group related statements together and use a single blank line to indicate a transition to a new step. This helps the reader scan and understand the flow. Consistency is the soul of clean code. Python enforces four-space indentation, but you should also respect the 79-character line limit to keep your code readable on any monitor. Manually checking this is tedious, so I highly recommend integrating automated formatters like black or linters like Flake 8 into your editor. Let the machines handle the style so you can focus on the logic. Clean code communicates its intent clearly. Use docstrings to describe the purpose and side effects of your functions, rather than just repeating the implementation details. Pairing. A common pitfall is using a list or dictionary as a default argument in a function. Because default arguments are evaluated only once at definition time, that list will persist across every single subsequent call to the function. Always initialize your arguments to none and assign the MP structure inside the function body to ensure a clean, fresh state every time. Wildcard imports are a recipe for namespace pollution and hidden bugs, as they make it impossible to track where functions originate. Instead, always use explicit imports. Organize your imports into three clear groups: standard library first, third-party packages second, and your local project modules last, with a blank line separating each group for visual clarity. Catching every error with a bare except block is dangerous because it masks syntax errors, keyboard interrupts, and unexpected crashes that you need to know about. To write clean, robust code, always target specific exception types. This keeps your error handling focused and prevents you from accidentally swallowing bugs that should have been raised to the surface. Ditch the older os.path strings and embrace pathlib. By treating file paths as objects, you gain readable methods for joining, checking existence, and navigating directories. It handles path separators automatically across different operating systems, meaning your code stays clean and portable without needing manual string concatenation or worrying about forward versus backslashes. When you find yourself writing long, winding chains of if-elif statements, you are likely missing an opportunity for dictionary dispatch. By mapping inputs to functions within a dictionary, you eliminate repetitive conditional logic. This results in a cleaner, more maintainable structure that is easier to extend when you need to add new commands later on. Context managers are vital. Here is our first key takeaway. Always prioritize readability over clever, condensed syntax. Python is designed to be read by humans, not just machines. If you find yourself writing a one-liner that takes 5 minutes to decode, you've sacrificed maintainability for ego. Write code that clearly communicates its intent so that future you or your team can understand it immediately. Second, encapsulate logic into small, single-purpose functions. A monolithic function that does 5 different things is a nightmare to debug. By breaking your project into modular pieces, you gain the ability to test each unit independently. Think of your code as a set of Lego bricks. When each brick has a defined, simple role, you can assemble them into any structure. Finally, leverage the Python standard library. Tools like pathlib and data classes are specifically designed to reduce boilerplate and prevent common errors. Why write custom logic for path manipulation or object initialization when the language already provides battle-tested solutions? Using these native features not only makes your code cleaner and more performant but also aligns your project with established, community-approved patterns. Time for a quick check. Which of these naming conventions is the standard for Python variables? If you guessed A, you are spot on. PEP 8 specifies that variable and function names should use snake_case, which is lowercase words separated by underscores. Capitalized words, or camel case, are typically reserved for class names, while all caps are strictly for constants.